All right. So on Monday we learned how to simplify radicals. If you didn't watch that video, go back and watch it to make sure you get that, because we're just going to do that part pretty quick today. Because today we're talking about adding and subtracting radicals. Two things to keep in mind. Must be the same radicand. The radicand means the stuff on the inside of the radical. That's got to be the same. Okay, it's kind of like combining like terms. And if it's not the same, see if you can simplify the radical, and maybe it'll end up being the same. No, I bet it will. All right, so real simple. If I have 15 root 3 minus 2 root 3, we add and subtract the numbers in front of the radical. Kind of look at those like if I had 15x minus 2x, remember back to your adding and subtracting rules, that would be 13x. Okay, the radicals don't change when you're adding and subtracting, just like the x's didn't change when you're adding and subtracting. Multiplication, obviously a different story, and we'll get into that soon. So this would be 13 root 3. If I have 15 of root 3's and I take away 2 root 3's, I have 13 root 3's. We're just adding and subtracting. Okay. If we have multiple radicals, we can only combine the ones that are the same. So again, remember your rules. I use the number in front of the term, never the one behind. So if I want to combine these two together, that is 10 root 3. This and this is minus 3 root 2. Remember, use the sign in front of the term, not the one behind. The minus goes to the 8 when you're combining like terms. All right, pretty straightforward. Take a look at number 3. Are those the same radicand? No, they're not the same, but I can simplify. So again, going back to yesterday, and I'm going to work up here. What goes into 50? 5 and 10. What goes into 10? 5 and 2. So I've got a 2, 5, 5 in my radical. 5's are coming out, 2 stays in, so this simplifies to 5 root 2. Do the same for 98. You may need a calculator, but you know it's an even number, so 2 goes into 98. 2 goes in 49 times, which is 7 times 7, so this is 2, 7, and 7. 7's get out. Now I have like terms. They both have a square root of 2. So I can add and subtract here. 5 minus 7 is negative 2 root 2. All right, that's what this process is going to look like for these problems. So let's take on number 4. What goes into 12? I got 4 and 3, 2 and 2. So I got a pair of 2's getting out. There's already a 6 out here. We talked about this the other day. I just multiply whatever comes out of the radical by what's already out of the radical, and that's 12 root 3. Next term, 72. We talked about multiple ways to do this. Obviously, you see me using the factor tree. I think it's the most straightforward. There's less of you trying to get inside my head. So I'm going to continue with the factor tree. If you know 72 is 36 times 2, and the square root of 36 is 6, by all means, you can get this pretty quick. If you want to go 36 and 2, most people probably go 8 and 9 with that. So I'm going to go where most people go. But if you want to start 36 and 2, that's easy. 8 and 9, 4 and 2, 3 and 3, 2 and 2. 2's out, 3's out, that 2 left in. If you are doing the factor tree method, stay organized, okay? You can't do this in your head. You've got to be neat and organized for this to work. I got a 2 out and a 3 out, that's 6. I got a 3 already out here, so that's 18. I have this 2 left in, so that's a 2. Next, 48. 48, what goes into 48? 12 and 4. 12, 3 and 4. Now remember, we talked about this and touched on this. I don't have to break those 4 down to a bunch of 2's. If you say a pair of numbers that's the same, I can take out a pair of 4's. That's a 4 on the outside, a 3 left on the inside. 5 times 4 is 20 root 3. Moving on, 36. If you recognize a perfect square, square root of 36 is 6. I don't need to go to a factor tree here. I know that this will break down to 6 and 6. Take the 6's out. All right? Take them out. 6 times 2 is 12. If something's a perfect square, remember, there's not going to be a radical. Everything's getting out. All right? However you want to think about it. It's a perfect square. The square 6 times 6 is 36. It works. Do we have any like terms now? Yeah, sure we do. And that's it. That's fine. 12 root 3 would be negative 8 root 3 minus 18 root 2 plus 12. Order. What order do you write those in? I'll be perfectly honest. I don't know any hard and fast rules for writing those answers. Just make sure all your pieces are there, and I think you're good. I honestly don't know any hard and fast rules. Sometimes I think some people would tell you to put this first, the constant first or last. I don't care, as long as it's all on there. All right, do these on your own. If you're at home, pause the video, work them out. If we're on campus, I'll pause the video and work them out. But here's the answers. So root 5 plus root 5. Remember, this is 1 root 5 and 1 root 5, so this would be 2 root 5. We're just adding and subtracting here. All right? Number 2, find the like terms. 6 plus 5 is 11 root 3 minus 10 root 2. All right? If you can break down the radical, you break down the radical. 75 is 25 and 3, 5 and 5. Five root 3 minus 3 root 3, 2 root 3. All right. Lots of breaking down here. 18 is 9 times 2, 3 and 3. Two's out, 3's out, 5 left in, so that's 6 times 2, 12 root 5. If you have questions, make sure you're asking. Let's combine the like terms. 18 root 2 minus 18 root 2 is 0 root 2. Don't write it. 21 root 5 minus 12 root 5 is 9 root 5. You got questions. I got answers. Ask them now. Good luck.